This is an example of a state chart for the Eastern Interconnection. What we'll do is play this in double real-time speed so you can see the behavior of the grid under normal conditions. First thing we'll observe is that there is a cluster of frequency points that are from Danbury, Connecticut. This shows that Danbury is operating independent of the rest of the grid. Now the state chart, which we also call a worm chart, is a plot of the frequencies of the stations in the Eastern Interconnection plotted on the y-axis versus the frequency of Knoxville, which is the base station in the interconnection. So you'll see that we have Danbury operating entirely asynchronously from the rest of the grid. Now you'll see the case where the Danbury has lost load in its area and the frequency has dropped down to 59.9. Most of the other stations in the grid have also dropped down to 59.9 with respect to Knoxville. So this is again saying that the system is operating as two separate asynchronous machines. However, the Danbury trace, you can see, is trying to get into this cluster operating at 59.9. One other observation is that the Danbury correlation line, this line here, is negatively correlated with Knoxville, which means that when the Knoxville frequency goes up, Danbury frequency goes down. Well, that's not an indication of a coherent grid. So you can see we're basically operating the grid as a multitude of very small systems. These are often called typols in a Zaborski-Illich textbook. This showing that we have many small systems that are operating nearly synchronously, but in effect they're operating asynchronously. And we can clearly see now that Danbury is starting to operate synchronously with Knoxville. It's because of the slope of this line is now positive. So we have Danbury and these stations here are all operating positively, but we still have negative correlation on these two stations. So you can see the system is now trying to recover to get back into what we call a safe region of state space. This is the plus or minus 0.05 standards from NERC. You can see Danville is operating within the standard, and now a few of the stations are getting close to operating within the NERC standards. We still have a reasonable amount of clustering. Now we have these stations that are all operating very close to synchronously. However, we have these stations which are not operating synchronously. This is in Canada and South Dakota. So Canada and South Dakota are lagging behind the rest of the Eastern Interconnection, but they're trying to catch up. Now you can see the system is turning back into a stable region. This is what is often called a limit cycle, that the system is very slowly operating at a slow limit cycle to try to achieve stability in the area. It looks like the limit cycle is probably on the order of 2 or 3 minutes. And now you can see most of the Eastern Interconnection is now operating back within the NERC standards. We still have some issues in the grid. These cross-correlation lines should be at 45 degrees, but you can see they're not, and they also should definitely have a positive slope. So here we show a positive slope. This is a good sign. Here's a negative slope. That's not a good sign. We can see that Danbury is now area is starting to operate as a separate synchronous machine. And this concludes the demonstration of frequency state charts in the Eastern Interconnection.